Good day, class. You're welcome to the class. Let us take a look at how to design flat belt. There is a question here that says a flat belt is required to transmit 30 kilowatt from a pulley of 1.5 meter effective diameter running at 300 RPM. The angle of contact is spread over 11 over 24 of the circumference. The coefficient of friction between the belt and the pulley is 0.3. Determine, taking centrifugal tension into account, width of the belt required. It is given that the thickness of the belt is 9.5 millimeter. Density of the material is 1,100 kilogram per meter cube, and the related permissible working stress is 2.5 megapascal. Now let us start. Solution. Let us look at our given. What are we given? We are given the power to be equal to 30 kilowatt, which is equal to 30 times 10 raised to the power 3 watt. We are also given the effective diameter of the pulley, D, which is equal to 1.5 meter. From here, we are also given the speed of rotation of the pulley, and which is given as 300 RPM. Then we are given the angle of contact of the belt to be 11 over 24 of the circumference, that is multiply 360 degrees, and this will give 165 degrees. Then we'll convert this one to radian by multiplying it by pi over 180, and this will give 2.88 radian. Also, we are given the coefficient of friction to be 0.3 and the thickness of the belt to be 9.5 mm, which is equal to 0.0095 meter. Then we're given the density of the material of the belt to be 1,100 kilogram per meter cube, and we're given the permissible working stress to be 2.5 megapascal, which is equal to 2.5 times 10 raised to the power 6 Newton per meter square. Now let's start. So let T1 be the tension on the tight side of the belt. Then T2 will be tension on the slack side of the belt. Then the velocity of the belt V is given by pi dn over 60. We'll substitute V is equal to pi times 1.5 multiply 300 divided by 60, and when we evaluate this one, this will give us 23.57 meter per second. Then we know that the power transmitted P is equal to T1 minus T2 multiplied by the velocity. That is, power is equal to T1 minus T2 multiplied by the velocity. When we substitute, power is 30 times 10 raised to power 3 is equal to T1 minus T2 multiplied by the velocity, which is 23.57. Then we have T1 minus T2 is equal to 30 times 10 raised to power 3 divide 23.57, and this will give 1273 Newton. That is, T1 minus T2 is equal to 1273 Newton. So we call this one our equation 1. Then also we go to our relationship between T1 and T2 given by 2.3 log T1 over T2 is equal to mu theta. When we substitute the value, which is 0.3 multiply 2.88, it will give us 0.864. That is 2.3 log T1 over T2 is equal to 0.864. Now we divide both sides by 2.3. We have log T1 to T2 is equal to 0.864 divide 2.3, and this will give 0.3756. That is, log T1 over T2 is equal to 0.3756. Then we take antilog of both sides. When you take the antilog of log T1 over T2, it will give us T1 over T2. When we take the antilog of 0.3756, it will give us 2.375. Now, we call this one equation 2. Now, solving equation 1 and 2, then we get our T1 to be equal to 2199 Newton, and T2 will be 926 Newton. Now let B be the width of the belt required. Then we know that the mass of the belt per meter length is given by mass of the belt per meter length. M is given by M is equal to the area of the belt multiplied by the length of the belt multiplied by the density of the belt. This implies that M is equal to area of the belt is the width of the belt multiplied by the thickness of the belt times the length of the belt times the density of the belt. Then from here, we substitute what we have. The mass of the belt is equal to the width of the belt times thickness of the belt is 0.0095. The length of the belt is 1 meter, and the density of the belt is 1100. Then when we evaluate this, we are going to get 10.45 B, which is in kilogram per meter. Then also centrifugal, centrifugal tension, TC, is given by mv squared, which will be equal to the mass, which is 10.45 B from here, multiplied by the speed, which is 23.57 squared. When we evaluate this one, we are going to get 5805 B, which is in Newton. Then also, we know that the maximum tension in the belt, maximum tension in the belt, T, is given by T1 plus the centrifugal tension. And this gives T1 plus Tc, and that maximum tension is given by the stress multiply the area of the belt, which is equal to stress times the area of the belt is belt width times its thickness. Then from here, our T1 is given as 2199 as we have calculated, then plus our TC, which is 5805 B, then is equal to the density is given as 2.5 times 10 raised to power 6 multiplied by the width of the bed multiplied by the thickness of the bed, which is 0.0095. Then we have 2199 plus 5805B is equal to, when we multiply this one, this will give us 23,750B. Then from here, we collect the like times. We have 2199 is equal to 23,750B minus 5805B. Then when we subtract this one from this, we are going to have 2199 is equal to 17900B. Then we divide both sides by this. We have B is equal to 2199 divide 17900, and this will give us 0.122 meter. Thank you very much for listening.